Welcome to The Explainer. Today, we're diving into the true story behind literally one of the most famous moments in scientific history. We're talking about Benjamin Franklin. You know him, diplomat, founding father, legendary inventor. But we're zeroing in specifically on his relationship with electricity. We're going to see what really went down during that famous storm, and I'm telling you, we're going to uncover some absolutely fascinating historical truths along the way.
So let's just start right here with the classic question. Did Benjamin Franklin discover electricity? If you ask around, most people will immediately picture the kite, the key, and say, well, yeah, of course he did.
But actually, no. If you look at the historical record, the answer is a flat-out no. Today, we're going to look at what his actual and, honestly, way more impressive achievement really was.
Section 1. The Great Electricity Myth. What really happened in the storm. There is a massive gap between those dramatic historical paintings we've all seen and scientific reality. We all know the myth, right? Franklin standing bravely in a torrential downpour, holding a string while this massive bolt of lightning directly strikes his kite. But the scientific reality is totally different. Franklin did not get struck by lightning. Instead, he observed an electrical charge that was simply induced by the ambient energy of the storm. That energy traveled down his string and resulted in a very small spark.
And how are we so sure it wasn't a direct strike? Well, the current in a standard lightning bolt is tens of thousands of amperes. If that kind of raw, unadulterated power had directly hit Franklin's kite and traveled down to his hand, he would have been killed instantly. There'd be no founding father, no Declaration of Independence, no story to tell. It was an incredibly dangerous situation for sure, but it was absolutely not a direct strike.
Okay, moving on to Section 2. The world before Franklin, a spark of understanding.
You see, electricity was actually known way before Franklin. Going all the way back to around 600 BC, the Greek philosopher Thales of Miletus noticed that rubbing amber with fur made it attract feathers. That's static electricity. Fast forward to 1600 AD, and English scientist William Gilbert studied this, officially coining the term electricus, from the Greek word for amber. And by the 1700s, right before Franklin's big moment, scientists across Europe were already treating electricity as a known thing. They were using friction machines and Leyden jars, which were basically early capacitors, to store electric charge. But while it was a really neat parlor trick, they didn't really understand how it behaved out in the natural world.
Enter Benjamin Franklin. In the 1740s, he became totally obsessed with this phenomenon. And here's where his genius really shines. He proposed that electricity was a single fluid moving between objects. He actually introduced the terms positive and negative charge to describe if an object had an excess or deficiency of this fluid. So the crucial takeaway here is that Franklin didn't discover electricity. He gave us the fundamental language and conceptual framework to understand how it behaves. Concepts that, by the way, scientists and electricians still use every single day.
Section 3. The famous kite experiment of 1752.
Franklin had this really bold hypothesis. He believed that the static electricity created in European labs and the terrifying lightning up in the sky were the exact same thing. To prove it, he gathered some shockingly simple materials: a silk kite, a length of hemp string, a plain metal key, a silk ribbon to insulate himself, and a Leyden jar to collect the charge. That's literally it. No high-tech lab equipment, just everyday items repurposed for an incredibly dangerous demonstration.
Let's break down how this builds into the moment of truth. Step 1, the storm rolls in and Franklin flies that silk kite up into the ominous clouds. Step 2, it starts to rain. Now this is critical because the hemp string gets wet, making it highly conductive. Step 3, the immense electrical charge from the storm's atmosphere starts traveling down that wet string, pooling and accumulating directly on the metal key tied near the bottom. And finally, step 4, the tension peaks. Franklin reaches out, moves his bare knuckle close to the key, and zap! He observes a small spark jump from the metal to his skin. In that single moment, he proved that storm clouds contain electricity. Atmospheric electricity and laboratory electricity were officially united.
I really cannot overstate how incredibly lucky he was to survive this. Just 1 year later, in 1753, a Russian scientist named Georg Wilhelm Richmann attempted a similar lightning study. He wasn't as fortunate. He was struck and killed instantly. Franklin was playing with fire here, literally the fire of the gods, and somehow managed to walk away with a scientific breakthrough rather than a tragic end. But you know, Franklin wasn't just a theorist. He was a deeply practical guy who wanted to solve real-world problems.
Which brings us to Section 4, Taming the Lightning, the Practical Application. This leads directly to Franklin's greatest practical invention from all of this, the lightning rod. Before this, a lightning strike on a wooden home or a church could easily burn the entire structure to the ground. But Franklin designed a brilliant solution. You just install a pointed metal rod at the very highest point of a building and connect it with a thick conductor that runs all the way down deep into the ground. When lightning strikes, instead of blowing apart the roof and starting a massive fire, the current takes the path of least resistance. It flows safely down the rod, right through the conductor, and harmlessly into the earth. Today, this exact same invention protects our homes, factories, and towering skyscrapers, saving countless lives and billions of dollars in property.
Section 5. An enduring scientific legacy, sparking the modern world.
By proving that charge is conserved and that lightning is electrical, Franklin laid the very foundation that allowed absolute titans of science to build the future. Think about this lineup of scientists. You've got Alessandro Volta inventing the electric battery, André-Marie Ampère laying the foundations of electrodynamics, Michael Faraday discovering electromagnetic induction, James Clerk Maxwell mathematically unifying electricity and magnetism, and of course, Edison and Tesla bringing practical lighting and AC power transmission to the masses. None of this cascading wave of innovation happens exactly this way without Franklin first demystifying that spark.
And because of that groundwork, built upon by all those subsequent scientists, we have the modern world. The electric motors in our appliances, the power stations lighting our cities, the computer or smartphone you're probably using right now to watch this explainer, right down to modern electric vehicles. All of it traces its lineage back to a man standing in a storm with a silk kite and a key.
But before we wrap up, I want to leave you with one more number, the number 2. Take a guess at what this represents. 2 assistants, 2 failed attempts? No way. This world-changing genius had only about 2 years of formal schooling in his entire life. Just 2 years. Everything else was driven purely by his own relentless curiosity, observation, and self-education. And that curiosity just couldn't be contained to one field. On top of his electrical work, he invented bifocal glasses, the highly efficient Franklin stove, and even a musical instrument called the glass harmonica. On the civic side, he was instrumental in drafting both the U.S. Declaration of Independence and the Constitution. But honestly, perhaps the most telling fact about his character is that despite these incredibly lucrative inventions, he refused to patent a single one. He firmly believed that knowledge and scientific advancement should freely benefit everyone in society.
So, as we conclude this explainer, I really want to leave you with a question to ponder. Benjamin Franklin didn't discover electricity, right? But he fundamentally transformed our understanding of it. He bridged the gap between abstract scientific theory and life-saving practical application, armed with little more than 2 years of schooling and an insatiable desire to understand the world. If that level of basic curiosity can literally spark the modern world, what will your curiosity discover next? Thanks so much for joining me on this journey. Keep asking questions, and I'll see you next time.